Okay, so on 1.3 notes, we're going to look at some properties of limits. And so this is good. It's going to be something new, but in the midst of doing this, we're going to practice what we already know about limits, and it's going to be a good review. All right, so let's say that we know two limits. I don't know the two functions, but I know that the limit as x approaches c of one function is L, and I know that on an entirely different function, entirely different graph, the limit is equal to k. Okay, that's given. We have these 6 properties that we can use that are really going to make our life easier when we're finding limits. It's going to prevent us from doing a lot of work. So scalar. Have you seen this word scalar before?
Physics.
Yeah, what does it mean?
It's just it has, like in physics it has like speed but it doesn't have any direction.
Yeah, so it's like a constant in math.
Yeah.
So a scalar is just a number. It's the most easiest thing that you can do to a function is just double it or something like that. So that's what we're doing. But remember, we don't really know what the function is, so I can't multiply it by a number and then take the limit. The nice thing is this b can go right out front, and instead of multiplying it by the function, I can multiply it by the limit. And the limit of f of x is L. So you would just be multiplying b times L. And so at this point, you may be thinking, okay, that seems obvious, but I don't understand what it really means. It means that you're going to get out of a lot of work in the future when we're using these properties. It means that you're going to get to do less algebra. All right, on the second one, sum or difference, it's saying if we needed to add 2 functions and then take their limit, that would be the same as if I knew the 2 limits, we would just add or subtract them. It's exactly what you'd think it would be, in other words. There's no extra work, there's no trickiness to any of this. So in going with that, number 3 product, the limit of f of x times g of x, what do you think that equals? L times k. So instead of having to multiply 2 functions together and then take a new limit, you could just multiply the 2 limits together. And remember, limits are numbers. L and K are just representing numbers. So multiplying 2 numbers is a lot easier than having to do a whole bunch of algebra. Okay, what about 4? What do you think that's equal to? There you go. And number 5. This looks weirder, but I'm going to go ahead and tell you it's nothing weird about it, really. Yeah, the limit of f of x is L, so we're just going to take the limit to the nth power. Now, composition. Do you remember in Algebra 2 and in pre-cal when you did f of g of x, where instead of plugging a number in, you had to plug a whole other function in? Do you remember how gross that got sometimes? This is going to get you out of that work, okay? So if I am, again, I'm giving you 2 different limits, or maybe you're finding 2 really simple limits. And then I say, okay, well, what's the limit of the composition of functions? You don't have to take the composition of functions. What you can do is go ahead and, just like how we moved that scalar, we're moving the f of out. We're not multiplying by f, we're doing f of the limit as x approaches c of g of x. And do you remember what this limit was? Yeah, k, so the answer is just going to be f of k. So instead of having to do composition of functions with limits, we could just plug the number, whatever k is, plug that into x in the f of x function. All right, so I know some of you, though, really learn by example. So this is for you. All right. So we're given 2 limits. The limit as x approaches c of f of x is 9, and then on a whole nother function g, the limit is equal to -2. I still don't know what the 2 functions are, but you don't need to know, okay? And if we did know, we wouldn't be using them anyway. So in looking at part A, the limit as x approaches c of 4 times f of x, this 4 right here can just go right out front, and then what you're left with is the limit of f of x, which is 9. So you're just multiplying 4 times 9, and that's the answer. So even if we were given the functions, we wouldn't want to use them here. This is a much more direct way of finding the limit. Okay, so what do you think about part B, the limit of f of x plus g of x?
The f of x outside.
So we're not multiplying. We're not going to bring this outside the same way we did before. Yeah, 9 plus negative 2, which is how much? There we go. That's it. Okay, what about C? Yeah, 9 to the negative 3 halves. Now, can anybody tell me what 9 to the negative 3 halves is? This is probably one of those things that's just like behind a few more cobwebs in your brain. It's in there.
1/9.
Okay, I'm hearing 1/9. You guys are close. Okay, so let me go on what you have right. The 1 over part is right. Can you tell me why you know that it's 1 over something?
It's negative exponent.
Because the exponent's negative. That means we're going to take the reciprocal of whatever 9 to the 3 halves is.
1 over.
All right, 1 over 27 is correct. So let's get there let's have everybody else get there. The 3 is a cube. 9 cubed. Do you know what 9 cubed is? 9 cubed.
Wow.
Yeah, that's not a common known fact. You may have it memorized or you can come up with it, but I don't really want to cube 9. So let's do the cubing at the end. What does this 2 do? Square root. So I'm going to square root the 9, which is 3, and then I'm going to cube the 3. That's why it's 27. So those of you that were getting 1/9, you got it?
It's the square root of 729 is 27.
Wait, say that again?
It's the square root of 729, 27.
It's not that high.
It's not that high. Okay.
I don't remember. But that's okay. We don't need to do it. And all of this stuff I do want you to be able to do without a calculator, but truly on something like this, it would be on the calculator part of a quiz or a test. Okay, so don't freak out if you're thinking, I don't remember at all how to do this, but let's get it figured out. Okay? Number 12. You know, like how it went 1 through 6, then 1, then 12? Okay, some of you probably didn't even notice. All right, so here we have 2 functions. So they are giving us the functions this time. And they're just asking us one question. Find the limit as x approaches 3 of f of g of x. Now, does anybody in here want to find f of g of x and then take the limit? No. If you just love algebra, you might. All right, so let's use the number 6 property here. That means that the f of can go in front, and I can have f of the limit as x approaches 3 of g of x. Now, I don't know the limit as x approaches 3 of g of x, like they don't give it to us, but this is really good review of what 1.2 is over, what we went over yesterday. So let's find the limit as x approaches 3 of g of x. What is that? Yeah, you plug in 3 right here for x, you get 15 minus 10, and that equals 5. So this whole thing is 5. We got that just by plugging the 3 in. Now you're going to find f of 5. So how do we find f of 5? You plug it in again. Now this one's just a little bit more, but this is still something you can do without a calculator. So the 5 squared is the 25, that's 75, minus 10, plus 5, 70. That's your answer. So a little bit of number crunching versus a lot of algebra. If any of you are curious, feel free to go back on your free time and do f of g of x and then plug 3 in. You're going to get the same number. Okay? All right, so let's look at the next page. So 13 and 14 are 2 examples again of where we're going to use this composition function. I see a sine and I see a natural log. It's okay. It's not that big of a deal. I know this is composition because I'm taking sine of a function. I'm not taking sine of a number here, sine of a function. So I want you to write this at the top, composition. You can abbreviate, that's fine. So that means I'm going to do the same thing I did in number 12. I'm going to move this sign, and I'm going to end up taking sine of the limit as x approaches 1 of f of x. So the next thing to do would be to actually find the limit as x approaches 1 of f of x. This is review. This is the stuff that I want you to be getting better at today than you were yesterday. So as x is approaching 1, as x is really, 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 really close to 1, what is y really, really close to? 3. You're right. This right here. It's not because it's the whole, it's because it's on the graph. It's because the left and right behavior are right there next to it. This point does not determine the limit. So the limit here is 3. So we're going to write sine of 3. And for now, we're just going to leave our answer of sine of 3. If I were to tell you, plug it in your calculator and round it, you could. Y'all want to know, by the way, one of the best things about calculus? You're not going to have to be switching back and forth between radians and degrees. We're just going to be in radians all the time. Okay. So I want you to look at the number 3, or number 13, and I want you to try 14 on your own. It's very similar.
So, this point over here is not matter.
When I'm finding the limit, that point doesn't matter. Right. If I asked you, what is f of 1? Well, then you would look to that point. Yeah, on the graph is where the limit is. The limit has to do with where the graph is getting really close to. Yeah.
So I'll write that, but as far as the f of x goes, like when you do that,
This is just, f of x is just referring to the function. Because you have to take the limit of something.
okay, that makes sense.
And it's the function.
And it's just stating that you're taking the limit of the actual picture.
Right. And a lot of that is just notation. Okay, so hopefully this was your first step. What is the limit as x approaches 2 of f of x?
2 from 3.
2. So we have natural log of 2. Could we plug that in and get a decimal? Of course we could. For today, we're just going to leave it as natural log of 2. Okay? All right. Now we're going to get into some more interesting algebra. All right. So, limits, equations. How do we find limits of an equation or of an expression? What was that first thing we always wanted to do? Direct substitution. Go for it. Okay, what did you get? 0 over 0. What does that tell us about the graph? There's a hole, and this looks a little bit different than the factoring problem we had, doesn't it? It's not, I'm not going to do the same type of thing. Okay, so I do see some denominators, and when I see denominators and fractions, that makes me think of something called LCD, least common denominator. All right. So look at these two little denominators, 5 plus x and 5. If those are your two little denominators, okay, and I'm not going to include x because really down here, the denominator of the denominator, how confusing is that? I know, is 1. And so 1, 5, 5 plus x, that's going to make this our LCD become 5 and 5 plus x. And this is a complex fraction. You have been doing this since Algebra 2, even if you were in regular Algebra 2. It's just not everybody's favorite thing. There are several different ways to do this, and I think what I'm showing you is the easiest way. All right, so what we're going to do is we're going to multiply the numerator and denominator by this expression here, 5 times 5 plus x. Because whatever we do to the top, we have to do to the bottom. And my hope is that somehow enough is going to cancel so that I can plug in and not get 0 over 0 anymore, but get an actual number. Okay, so let's think about this. We're going to take 5 and 5 plus x, and we're going to multiply it to each of these terms. I mean, think of it this way. We've got to distribute. Okay? Got to distribute here. So let's go ahead and write our limit. We need to write limit every time until we actually take the limit. Don't leave that off. This is just a good habit to get into now. Okay, so 5 times 5 plus x. When I multiply that to this first term, 1 over 5 plus x, what happens? What cancels? The 5 plus x's. And so you're left with 1 times 5. So that simplified very nicely. Let me say that again. 5 times 5 plus x. When I distributed it to the very first term right here, the 5 plus x canceled, and we were left with just a 5. Okay, then I have a minus, so I'm going to subtract something. Now when I multiply 5 times 5 plus x to this 1/5, what's canceling now? The 5's are going to cancel, and you'll be left with 5 plus x. But because I'm subtracting it, I'm going to go ahead and put parentheses there, because you got to make sure, if you subtract a single number, that's fine. But when you subtract an expression, we're going to have to distribute that negative. Okay, look at the denominator. Nothing cancels. So I'm going to write the 5 first because it's a number, then I'm going to write the x, and then I'm going to write the expression 5 plus x. All right. So some things happened, but I can already tell on top. If I distribute the negative, it's going to get a little bit easier. So let's do that. 5 minus 5 minus x. This is why it's important you have parentheses here. 5 minus 5, well, that goes away. That's 0. So I'm going to totally scratch that out. Let me ask you. Do you think we should distribute the denominator? Those of you saying no, tell me why we don't want to distribute the denominator. Yeah, look at that x right here. This x right here can cancel out with the x on the bottom, but not if I distribute it through. Okay, so let's take this x and divide it by this x. But this becomes a 1. Don't forget that. When everything goes away, you still have a 1 there. Now I canceled out quite a bit. So let's try to plug the number in. If you still get 0 over 0, then we're not done with the algebra. So when I plug 0 in for x, I get negative 1 over 25. And that's your answer. So when the x values are really close to 0, the y values are really close to negative 1 over 25. That's what the limit means. At x equals 0, there's a hole. Okay, 20. 20 is a little bit different, but not too much. Let's go ahead and do direct substitution, though. We always want to try that first, because if it's just that easy, then you really don't want to be doing extra work. Okay, what happens? 0 over 0. All right, so 0 over 0. Can I factor this? No. Can I do least common denominator on this? Does it look like number 19? No. This, though, has a square root. When you see a square root, you need to be thinking this word conjugate. Have you heard of this word before?
Yes.
Yes. Good memories? Bad memories?
Yes.
Good? Okay. Those of you that are like, that's okay. All right. So we're going to do the same thing we did up there. We're going to multiply something to the top and the bottom, but it's not going to be the LCD. It's going to be the conjugate of this, of right here, okay? So the conjugate's going to be the same square root, but instead of minus 1, it's going to be plus 1. Because this is going to cancel a whole bunch of things out. This, again, is what I was referring to about the calculus part's not too hard. It's the algebra part that can get kind of tedious. So remember, multiply the denominator as well. Next, we just need to keep writing limit until we actually take the limit, meaning when we actually plug 0 in for x. Okay, conjugates. The reason they're nice is because when I multiply these two, what's square root of x plus 1 times square root of x plus 1? Just x plus 1, so that was nice. What's also, and I'm going to do this in green, what's going to happen when I do the outside and the inside? They're going to cancel. One of them is positive square root of x plus 1. One of them is negative square root of x plus 1. So I'm actually not even going to write that down. When you're doing the conjugate, this is a part you could skip. That's fine. We still, though, do need to multiply the negative 1 times the positive 1. This is just like FOIL, like double distribution, however your teacher taught it to you. The denominator, we're just going to write it like last time. I am going to put parentheses around this conjugate because I need to make sure I'm multiplying x by the whole thing. What do you think? What can we do? Make our life easier. Cancel plus 1, minus 1. What else? Okay, so did this look similar to the one we just did? Yeah, the first step was different, but really after that, it was very similar. Nothing's left on top. What do I need to write? 1, and that's really important. If you don't do that, you're going to get the final answer wrong. I think we're ready to plug it in. What happens when we plug 0 in for x now? What does the denominator equal?
2.
Okay. And so this, these, and here's another factoring one. I'm not going to work this one out right now, but because we've already worked out a few factoring ones. Factoring, LCD, conjugate, those are what you're going to look for when you get 0 over 0. These are your algebra steps you're going to look for. Okay?